Hey everyone, so today we'll still be doing complex numbers. This time though, we'll be sketching subsets on a complex plane. So what does that mean? Well, let's have a look at this equation, this question. Sketch the subset of the complex plane where S, colon, then you got this equation, z plus 5i minus z minus 5i under mod equals to 6. So how are we supposed to sketch a graph that doesn't even have an x or y value? Well, as we all know, z has a real component, so z is a complex number, meaning it has a real component, and it also has an imaginary component. In this case, we can let our real component be x and our imaginary component be y. And that's where you get your x and y values. You substitute x plus y into every z value you see into your equation, then you'll be able to work out those what kind of equation it's going to give us, and then we can sketch our graph afterwards. Okay, let's have a look on what this subset over here looks like. Okay, so step number one, of course, z equals x plus yi, and we just sub it in. So we have mod z plus yi, so that's the z over here, becomes x plus yi. We still have plus 5i and then minus mod x plus yi. So it's always x plus yi for every z value. Minus 5i, that comes over here, equals to 6. Right, so that's our equation. Don't worry about the z over here. Don't worry about the s. That's just part of the formalities when you're writing these kind of subsets on complex planes. Okay, and then afterwards you group the real component and the imaginary component together. You have x by itself, y plus 5i, minus x once again by itself, y minus 5i equals to 6. Okay, so when we're up to that point, when you're trying to find the mod of a complex number, let's just say z was 1 plus I, right? And if I wanted to find the mod of z equals 1 plus 5i, what I would do is I square the real component, and then I also square the imaginary component. Then I add them together and root them afterwards. You do the same thing over here. So what we have is we square the real component, which is x. We square the imaginary component, which is y plus 5. Don't worry about the I. The I is not part of your imaginary component. And you do the same to the left-hand side. If you want to find the mod, square x, and you still just have y minus 5 square. And then if, so what you can do here is, well, just leave 6 over here. But afterwards, you can bring one of this to the right side, or you can square both left-hand side and right-hand side to get rid of the square root. So there's many ways you can branch out, but preferably, what I like to do is I bring one of them to the right side, because that just takes out, it just means less work, and you'll see why. So y plus 5 square equals to 6 plus x square plus y minus 5 square. Okay, so we shifted the x square plus y minus 5 square over to the right hand side, and we just keep doing our algebra. So I'll just do that over here. We square the left hand side to get rid of the square root, but of course if you square the left hand side, you have to square the right hand side as well, and that's what we have. Okay, so if you square a square root, the square root knocks out. I will also expand out y plus 5 square, so that's y square plus 10y plus 25. So if you expand y plus 5 square, then on the right hand side, well, 6. So we have a plus b bracket bracket square, so we get a square plus 2ab plus b square. So in this case, a square plus 2ab plus b square. So in this case, 6 becomes 36, that's our a, we get a square. Then we have plus 2ab, 2 times 6 is 12, and we treat this as our b, so that's 12 x squared plus y minus 5 squared. And don't worry, it might look pretty ugly right now, but you will see eventually it will look very nice. Then of course you square the b value, which in this case you take out the square root and you have x squared And to make it shorter, to make it faster, I'll square the bracket over here, minus 10y. The reason why we do that is so that we can take out some of our x squared, y squared values, as you can see, to make life, a little bit easier for us when we're doing these calculations. Okay, so what do we see here? X squared, y squared, and y squared. They're the same on both sides, so you can cancel them out. Now, this is negative 10y, that is 10y, so don't cancel that out, although we can still cancel out 25. We need to bring that negative 10y to the left-hand side, and we get 20y, because 10y plus 10y is 20. We can also bring the 36 to the left-hand side over here, so that we're left with y values on the left-hand side. Well, we still have this, but now things look much better than as we have over here. So we have 12 x squared plus y minus 5 squared, and that's much better, it looks much nicer. Okay, now here's the here's where most students would lose a mark when we're sketching these kind of graphs. This only applies to hyperbolas. As you'll see, we'll get a hyperbola graph, but this is where students would lose their mark. 20y minus 36 equals to 12 root x squared plus y minus 5 squared. Well, we have to restrict our y value. That means we restrict the range of our graph. The reason being, I cannot have the left-hand side, so this side over here, the left-hand side, I cannot have it being a negative number because, once again, I need to square. So to get rid of this square root later on, I would have to square the left-hand side. However, you cannot, in maths, you cannot square a negative number. So if you had negative 3 equals to root x plus 1 or something like that, we cannot do negative 3 square. It's just within the maths terms, maths rules. So negative 3 we cannot x square that, so that means we have to restrict this. The left hand side cannot be a negative number. So how do we restrict that? Well, I'll do on the side over here. 20y minus 36 has to be bigger than 0. Because, big or equals to, then y has to be bigger than 36 on 20. If you simplify that, you would get divided by 4, you get 9 on 5. So y has to be bigger than 9 on 5 so that this equation will work. Because if you have a negative number, as you know, we cannot square a negative number in our equations. Okay, so let's keep moving along. Now you can do it two ways. If you want to get rid of the square root, like we did over here, you square both sides. But you can simplify things first because 20 and 36, 12, those are big numbers. Squaring them would be a little bit of a hassle. So you can simplify. Well, what's a good way to simplify this? Divide both sides by the common factor, so that's 4. So you're left with 5y minus 9 equals to 3 x squared plus y squared, y minus 5 squared. Okay, and those numbers we can definitely work with, much better than 20 and 36 and 12. So afterwards, we square both sides. So I'm just going to square both sides. And the reason we do that is to get rid of the square root. So we have 25y squared minus 2ab, so 2 times 9 times 5y. That, whoops, sorry there. That should give me 45y, so 90y times that by 2. And we have plus 81. Okay, and then on the right hand side, you square this. That's just one number. Don't treat this as two numbers. 3 root x squared plus y minus 5 squared is just one number. So we just square that normally. 3 squared is 9, and the square root cancels out. So we have 9 times whatever is inside. So I'm going to expand the bracket, y minus 5 over here, plus 25, so that we can cancel out things later on. Okay, so leave the left-hand side. Can't do much with that, plus 81. And we can expand the brackets. So 9x squared plus 9y squared minus 90y. Now 25 times 9, well, 9 times 5 is 45. You can put a 4 there. 9 times 2 is 18, plus 4 is 225. Okay, now we can start to simplify things. We can cancel out numbers. Let's have a look. Well, negative 90y and negative 90y, they are the same, so you can cancel them out. And 25y squared with 9y squared, if you bring this 9 to the left hand side, we end up with 16y squared. Same thing with the x, you can bring the x to the left hand side, which we get 9x squared. And of course, you bring 81 to the right hand side, you get, well, let's see, 22 minus 8 is 14. So you get 16y squared minus 9x squared equals 144. Now that's a good looking equation. Well, we still don't know what kind of graph it is, but if you did your circles, ellipse, and hyperbolas, you watch my first video, tutorial video, you'll know how to sketch those. You realize that, well, okay, we have y squared, we have x squared, there's a minus in between. This has to be a hyperbola. The general equation of hyperbola would have 1 on the right hand side. Then we have the y squared and x squared. So 16, to get 1, we divide both sides by 144. If you divide 16 by 144, we should have 9. And of course, 9 divided by 144, that should give us 16. Okay, well now this looks like our hyperbola and we can begin sketching our graph. Let's have a look. How do you sketch our graph? Well, let's just have a look at this equation. Our center is 0, 0. There's no h or k value over there. We know after you find your center for hyperbola, you get your asymptotes. So in this case, y equals to, or normally it's y minus k, but then since our k is 0, we just have y equals to plus minus b over a. So b is always the value under y. So in this case, 3. A is the value under x, that's 4. Remember, it's not 9 over 16, it's the square root of those. So 3 over 4, and you just have your x. So those are your asymptotes. Once you have your asymptote, we can easily sketch this graph. We know that because y is in front, x is at the, on the back, our graph should be of this shape. So let's start sketching that graph. Okay, so my graph's over here. Hopefully the sketch doesn't go that bad. Okay, asymptote 3 over 4x. I'm going to try my best. 3 over 4x, negative 3 over 4x. Make sure you label your asymptote. Y equals negative 3 over 4x. So those are your asymptotes. Now we sketch our graph. Well, if you watched the first video, you would realize that an easy way to do, an accurate way to sketch hyperbolas, circles, ellipse, you add the b or the a value, depending on what kind of shape this is, to the center. So in this case, since it's going up and down, so this shape instead of the horizontal one, the left and right, we have 0, the y value, plus it by the b value, so 3. So in this case, our graph starts at 3 and negative 3. Right, now you just sketch your graph, your hyperbola as normal, shouldn't take too much of a problem, and you get your graph. Unfortunately, once again, that's a common mistake for many students. You have to look back into your equation and see the range. We've set up before that y has to be bigger than 9 over 5, or else this equation wouldn't make sense. We can't have a negative number. So our range says y bigger than 9 over 5. Well, what does that mean on our graph? Well, in this case, where is it bigger than 9 over 5? Well, it's just the top part, right? 9 over 5 is approximately 1 point something, so it's over here. If you want values bigger than that, we can only take the top part. That means the bottom part of our graph, we should not be sketching that. So just rub that out. Should not be sketching any part of this graph. Once you rub that out, you get your graph, and that's what your graph should look like for this equation, this subset z. So mod z plus 5i mod minus z minus 5i equals to 6, and that's all. And that's all the tutorial today. Thank you guys for watching, and I'll see you next time.